blast out. This is very useful if you want to look at it, look at specific regions. Some of you in your projects will be doing something where you're actually going to look at individual similarities between proteins, and that will be useful. But you can also see at the same time that that file would be pretty hard to parse. It would be quite a bit of work to use Perl to go through that and get the information out of it. It's sort of intended for human eyes, not for easy scripting. So we can add one component to this, and that's -m8. So -m just says what format do you want the output to be. And 8 is a useful one. I don't actually know all of them. I haven't used most of them. So perhaps you'll want to explore that. But I haven't found them to be crucial. So this is going to give us a totally different format, one more similar to what we've been working on in class. And so we can do the same thing, and this time we'll put it in a file called BlastOut2. So again, I'm going to run this in the background with an ampersand just so that I can get the command line back, and we can keep talking about the file in this window. And so now let's see, it may take a while to print some stuff out. Nope, there it is. And so we can compare this to the other BLAST file we looked at. So in the other BLAST file, we had a first protein that did not show any hits. And in this case, it doesn't even tell us about that protein. Actually, that protein is missing. So this one that we're seeing, this was the second one in our file. Remember, this is the one that had an e-value of 0.053. And so here are our 4 hits. So these 4 hits contain pretty much the same information as what we saw before. So let's go, if we scroll down, then we can see this block. This block represents, remember, this really strong hit that we saw, and some other hits. Okay, so then the goal here is to figure out what is going on, what are these different columns. So this column is our input sequence. This column is our database sequence. This is the BLAST score. And then honestly, I'm not sure. Oh, yeah, this is the length of the alignment. This is the number of mismatches. Okay, I know I'm going fast, but in a second I'll show you how to get this information back. This is the number of gaps. That would be positions in the alignment where one protein has an amino acid and the other one does not. This says that our query sequence, this first sequence, that the alignment that BLAST found goes from position 14 to position 31 in that protein, and that's aligned to the database protein at positions 36 through 53. And then this is the e-value, and this is our BLAST score. I said one thing incorrectly there. I apologize. This is actually our percent identity. So notice that it's just our percent identity within this short aligned region. So within these 18 amino acid positions, there was an alignment identity of 61%, which is the 11 out of 18. And so then if we go down and look at our very good hit, we see 54% identity going from positions 18 to 575 and from positions 3 to 568 with a e-score of 0 and a BLAST score of 630. Okay, so once you've looked at this for a while, you can actually you'll remember where the different things are, though you notice I didn't remember all of them. But you can also sort of work it out by looking at it. However, until you're that comfortable with things, there's actually another thing that we can do. If we do M9, it's just going to give us the M8, plus it's going to give us a line explaining the columns. So let's do that. We can just put it in another file. And let's look at what we see. Okay, so again, this is the same thing as we saw. So there's our first protein with its 4 hits. But now we get a header for each one. So this header goes with this protein's results. Oh, my mistake. Actually, now we see a header that has the query that had no hits. So see, these 4 lines are the header, but then there's nothing after it. Then immediately we have our next header. That's for this protein. and we see our 4 hits here. So the main thing that I use in M9 is to just remind me with this line of what column is what. So this fields thing, that fields means columns. So the first field is query ID, that's this one. The second field is subject ID, that's this one. Percent identity within the alignment, that's this. Alignment length is 18 and so forth. So with M9, it will show us back what the meaning of each of these columns is. Basically, it will tell us the stuff that we just went through. Okay, so then I just want to teach us one more thing. So if we look at, remember we talked in this first hit, that this first protein, that all our hits had pretty bad e-values, not very confidence-inspiring e-values. So we might want to do something where we just eliminate this, where we ask the program to not give us back all these low-scoring hits, but to only give us good hits. And the way we would do that, so we'll go back to M8, so we don't have all that extra stuff to look at. And the way we would do that is with an E value, so -E, and then whatever we want our worst E value to be, our cutoff for an E value. So we could use, for instance, 10 to the -5th would be like this. And let's run that, see what it looks like. And so what we see, notice the first thing is that really high score that we had with the score of 0. All the ones before it that had low E values or bad E values have been eliminated, and now you can see we only see these better hits. So that was all I wanted to tell you, but I think while we're here, I'll teach you one more thing. And that one more thing would be, sometimes you just want to get one hit, right? So in all our files, we've noticed that a single protein will have many different hits. In this case, it looks like about 30. But sometimes we just want to get the best hit. And so BLAST has an option for doing that. And I actually can't remember which one it was. I use these two together. It's either -V1 or -B1. So let's see if that was the right one or not. Nope, it wasn't. See, we've still got all these others. So let's try that again. So apparently it turns out it's -B1 will give us only one hit. And so it's taking longer for this file to have any information because now BLAST still has to do all these big searches, but for each protein now it's generating at most one line. And it doesn't print out until it has a bunch of lines. And so here now we see this. We see that there's exactly one line for each. We'll see some cases where there are actually 2 lines. So down here we see that there are 2 lines, but notice these are 2 different hits between this protein and this protein. So basically we're looking at 2 regions where this align. So we can see the top one is aligning position 626 to 795 in our query, whereas the next one is aligning sequences from 96 to 299. So I think that's all. I guess, no, while we're here, if you're bored, you can stop. I'll teach you one more thing for those of you who are interested. Remember we saw that there was this thing where when we were using a normal BLAST, not with M8, that it would filter out repetitive sequences in our query sequence, turn them all into X's. If we don't want that to be the case, we can tell it, so F for filter, and we could say false. So FF, please do not filter. And what that means is that, so it was here. I think it was around here that it had filtered out. But in any case, it was somewhere in this protein that was all X's, and now we can see that it does not have X's. It's actually used the entire input sequence. Okay, so hopefully that'll help you on your homework. Good luck.